this video, we're going to discuss about the differentials and the applications of differential. Okay, so ano ba yung differentials? For example, meron tayong graph ng function. So let's say this is the graph of function f of x. Then let's say meron tayong c. Okay, so let's say we have c, then yung value niya ay f of c. Okay, then we have c plus delta x. So yung value niya ay f of c plus delta x. Okay, so therefore dito yung difference neto, that is delta x. Okay, now so dito meron tayong tangent line. So let's say meron tayong tangent line at point C. So ayan. So let's say ito ay ating tangent line. Then by the way, take note, yung delta x natin dito will be yung run natin. Okay, so dun sa derivative, no, ang ginagamit nating ano diyan ay dx. Okay? And then yung sa derivative natin, yung dy natin ito. So itong buong to yung dy. Okay, so ito yung ating dy. But the actual dy or yung rise natin, so ito yung difference ng f of c plus delta x and f of c. So this is our delta y. Okay. Now, as you can see, yung dy natin, so ito yon, yung dy is the approximation ng ating delta y. Okay? For dx equals delta x. Okay? So for example, kung kukunin natin yung derivative, so let's say let's say meron tayong function na y equals square root of x. So kapag kinuha natin yung derivative niyan, 'di ba? So that is dy over dx. That is 1 over 2 square root of x. Then multiply natin both sides by dx, so that we have dy equals 1 over 2 square root of x times dx. And as you can see, yung dy natin, so etong 1 over 2 square root of x, siya yung derivative ng y, di ba? So yung dy natin, that is f prime of x dx. And yung idea dito, yung ating dy, siya yung approximation natin nung rise. Okay? Or approximation ng ating delta y, which is ito. Okay? Kasi yung dy natin ay ito. Okay, so delta y is approximately equal to dy, which is equal to f prime of x dx. So ito yung ating differential of y. So yung differential of x or differential of independent variable is dx or delta x equals to delta x. And then yung differential ng y, which is approximation ng delta y, that is derivative of the given function times the differential of x. So for example, number 1, hanapin natin yung differential ng y equals x raised to 4 minus 2x cubed plus x plus 1. Okay? So ang gagawin lang natin, kukunin muna natin yung derivative niyan. So that is dy over dx equals 4x cubed minus 6x plus 1. And then imumultiply natin sa dx. Okay? So, yun yung magiging differential ng y. So, ganun lang siya kasimple. Kunin yung differential. Okay? Dx. Okay, so kung yung derivative rate of change, yung differential niya, siya mismo yung change in y. Okay, yung approximation of change in y. For number 2, let's have xy squared equals y plus x. Find the differential of y. Okay? So dito, ganun lang din. Implicit differentiation lang siya. So, eto product yan, no? So, x derivative ng y squared, that is 2y. 2y dy over dx plus y squared derivative ng x, that is 1, equals derivative ng y, that is dy over dx, derivative ng x, that is 1. Okay? Then, ayusin natin. So, 2xy dy over dx plus y squared equals dy over dx plus 1. So, pwede na natin i-multiply yan both sides by dx, pero sa akin, mamaya na lang. So, sa dulo na natin siya i-multiply by dx. So, ito, ilagay natin sa left side. Ito, ilagay natin sa right side. So, magiging 2xy dy over dx. So, from positive, magiging negative. Equals 1. So, ito magiging negative y squared. Then, i-factor out natin yung dy over dx. So, that is dy over dx 2xy minus 1 equals 1 minus y squared. So, divide both sides by 2xy minus 1. So, dy over dx, yan yung derivative, equals 1 minus y squared over 2xy minus 1. And then, saka natin i-multiply both sides by dx. So, ilalagay lang natin tong dx dito. So, magiging differential na siya. Y squared over 2xy minus 1 dx. So, ganyan lang kasimple. Kunin yung differential of y. Okay, so let's have number 3. Okay, so meron tayong dalawang problems dito. So for number 3, a ball 10 inch in diameter is to be covered by a rubber material which is 1 over 16 inch thick. Use differentials to estimate the volume of the rubber material that will be used. Okay, so dito meron tayong given. Okay, so for our solution, so para ma-imagine nyo, ang bola daw natin, so let's say ito yung bola, yung diameter daw niya ay 10 inches. Okay, so 10 inches yung diameter. So, yan, ito yung 10 inches. 10 inch. Okay, tapos, kukuberan daw siya ng rubber material. So let's say ito yung rubber material. Okay, na yung thickness daw nito ay 1 over 16. So, ibig sabihin, ito, 1 over 16. Okay? Now, ang pinapahanap sa atin, i-estimate daw natin yung volume ng rubber material, which is ito, yung volume nito, yung pinang-cover natin sa bola, using differential. Okay? Now, so kung 10 inches yung diameter ng bola, so ano yung magiging radius niyan? So yung radius niya, syempre yung kalahati, no? Kasi yung diameter, pag kinuha mo yung kalahati niyan, that is a radius. So kalahati ng 10 inches, that is 5 inches. Okay. So ito yon, yung radius 5 inches. Okay? Then ano ba yung volume nung yung bola kasi natin ay sphere, no? Now, ano ba yung ano yung volume ng ating bola? Okay? So yung volume ng ball, volume of the ball with radius r, so that is V of r equals 4 over 3 pi r cube. So yan yung volume ng ng radius ng bola. Okay? With radius r. So now, yung volume naman ng rubber material, so volume of the rubber material which is ito yung i-estimate natin using differential. So, volume ng rubber material, that is V of, ipagsamahin natin yung kabuoang volume muna. Okay? So, pagsamahin natin yung radius, 5 plus 1 over 16 minus yung volume ng bola natin, which is V of 5. Okay? So, itong volume ng rubber material, ito yung, kumbaga, nagre-represent doon sa change in volume nung kinubera na natin yung bola. Okay? Kasi yung, halimbawa, ito yung bola, kinuberan natin siya. So, nagkaroon ng pagbabago doon sa naging volume. Okay? So, that is delta V. At ito yung i-approximate natin or i-estimate natin using differential. Okay? So, delta V approximately equal to dV. Okay? So, this is equal to, so ang gagawin natin, kukunin natin yung derivative nito. Okay? So, derivative nito, that is 4 over 3 pi r squared. Then, dr. Okay? Now, so this is equal to 4 pi r squared dr. Okay? Now, ano yung radius? Yung radius natin ay 5, di ba? Binigay yung radius 5. So, ano yung dr? Yung dr kasi, ito yung change in radius. Okay? Which is yung 1 over 16. Kasi ang radius niya ay 5. So, nagkaroon din ng pagbabago syempre sa radius. Which is kasi binanggit yung thickness ng ating rubber material, which is 1 over 16 inch. Okay, so meaning nagkaroon ng change in radius, which is 1 over 16. So yan yung dr natin. So dr equals 1 over 16. So isa-substitute lang natin dito. So that is equal to 4 pi, radius natin, 5 squared, then 1 over 16. So yung estimation ng volume ng rubber material will be, solve lang natin to, that is 25, 4 over 16. No? So magiging over 4 na lang. So 25 pi over 4 cubic inches. So yan yung estimation ng volume ng rubber material na ginamit natin para ipang-cover doon sa bola. Okay, so by the way, in-assume ko na lang dito sa given na to na yung bola, usually naman kasi ang bola ay sphere. Okay, so let's say yung bola dito ay sphere. Okay, so last, number 4, a metal rod 15 centimeters long and 8 centimeter in diameter is to be insulated except for the ends with a material 0.001 centimeter thick. Use differentials to estimate the volume of the insulation. Okay, so dito meron daw tayong metal rod. Okay, so yan yung ginagamit natin sa construction, di ba, kapag gagawa ng bahay, no? Yung mga nakikita nating bakal doon na matataas. Okay, so halimbawa meron tayong solution muna. Metal rod, so halimbawa ito yon. So itsura kasi ng metal rod para siyang cylinder. Okay, so yan. Tapos, ang sabi, 15 centimeters long daw siya. So, ibig sabihin, ito, 15 centimeters. Tapos, yung diameter, 8 centimeters. Okay, so, ito yon, 8 centimeters. 8 cm. Okay, so, sabi ko nga, para siyang cylinder. Na, kumbaga, ito yung circle niya. Yan. Ito yan. So, kumbaga, ito yon, yung 8 cm. 8 cm. So, ibig sabihin, yung radius niya, 4 centimeters. Okay, so, maliit na. So, yung radius niya, mula dito, 4 cm. Now, ang gagawin daw, yung metal rod daw is to be insulated. Pero hindi kasama yung dalawang ends. So, hindi kasama to. Okay, so maglalagay tayo ng material. So, let's say ito yon. Okay? Then, dapat pala dito ko na nilagay. Then, yung thickness daw ng material na yun ay 0.001. Okay? So, ibig sabihin, yung radius nito, so, dito na natin. Ibig sabihin, ito, liit na. 0.001 centimeter. Okay? Now, ang gagawin natin, i-estimate natin yung volume ng insulation in terms using differentials. Okay? Now, so since hindi kasama yung yung dalawang ends ng metal rod natin, so ibig sabihin yung height natin, so ito hindi madadagdagan yung height. So magre-remain siya. Okay? Kasi kapag kasama yung ends, madadagdagan yan. Tinakpan din natin. Okay? So now, magre-remain lang to yung 15 centimeters. So meaning, yung magiging volume ng metal rod natin, since cylinder siya, yung itsura niya, will be pi r squared h, which is yung height natin or yung length na ito ay 15 cm. So 15 pi r squared centimeters. So yan yung volume. Okay? Then, yung volume ng nung material, okay? So that is V yung 4 plus radius ng loob tapos yung 0.001 minus yung loob, okay, para makuha yung volume ng material na pinangtakip doon sa metal rod natin. So V4. So ito yung change in volume, okay, or delta V. Okay? So, i-estimate natin yan using differential. So, delta V approximately equal to dV equals, so formula ng dV with respect to R, okay, so kukunin natin yung derivative nito with respect to R, so that is 30 pi R dr. Okay? So, ano yung R natin? Yung R natin ay 4, yung dr natin, change in R, that is 0.001. So, ito yung nadagdag, no? So, 0.001. So, substitute lang natin to dito sa formula. So, dV equals 30 pi. Yung R natin ay 4. dr natin 0.001. Okay, so yung differential, that is equal to, so compute natin, huwag na natin isama yung pi. So, 30 times 4 times 30 times 4 times 0.001. So, that is 0.12. So, 0.12 pi cubic centimeters. So, yan yung estimation ng volume ng rubber material nung material na pinangtakip natin dito or pinang-cover natin dito sa metal rod.